Okay, so there are a couple of things that I need to correct from yesterday because I did not read the directions. So it's very important to read the directions. So this is example 2 on page 179 or 180. And it says to write an equation in slope-intercept form. Yesterday when I did this example, I wrote it in point-slope form. So again, it's very important to read the directions, and that was my mistake. All right, so for this example, we're going to start by finding our slope like we did before. So we're going to go down 1, 2, 3, 4. So down 4, and then I run 1, 2. So negative 4 over 2, which simplifies to negative 2. And that again is our slope. Now for slope-intercept form, I also need to find the y-intercept. Since you look at this graph, you can't see the y-intercept since the line does not cross the y-axis yet. We have to get it into point-slope form and then manipulate it into slope-intercept form. So what I mean by that is if I was to write the line, this equation of the line in point-slope form, I would have y minus 2 equals negative 2 x minus 1. Oops. Okay. That's in point-slope form. Now I need it into slope-intercept form. In order to get it into slope-intercept form, we always have to get y by itself. So in order to get y by itself, I first need to distribute my negative 2. So negative 2x, and then distribute it there, so it would become plus 2 equals y minus 2. Okay? Now, I still need to get y by itself, so I have a minus 2, so I'm going to add 2 to make a 0 pair. So y equals negative 2x plus 4. That is in slope-intercept form. Okay, I need to make the same correction on example 3 because it wants a linear function. A linear function is going to be written in the form f of x equals mx plus b. So slope-intercept form, but you just use function notation. So again, you find the slope. So I have f of 4 equals negative 2. So that point would be 4 comma negative 2 and 8 comma 4. I can find the slope by finding y2 minus y1 over x2 minus x1. I'm going to go through and label my points. So this would be x1, y1, x2, y2. So y2 is 4 minus y1 is negative 2 over x2 is 8 minus x1 is 4. I get 6 over 4, which simplifies to 3 over 2. Okay, so I found slope. I'm going to write it in point-slope form since I don't have the y-intercept. So y minus, I'm going to use this point, negative 2 equals my slope, 3 over 2, parentheses, x minus 4. Okay, this actually becomes plus, but in order to get y by itself, I'm going to distribute. So I would have 3 over 2x minus 6, because 3 times negative 4 is negative 12, divided by 2 is negative 6. You can put that into a calculator as well. And then I still have y plus 2. In order to get y by itself, I'm going to subtract 2, y equals 3 over 2x minus 8. And that is in slope-intercept form. But since they want it in function notation, I'm actually going to write it as f of x equals 3 over 2x minus 8. Okay, so the example that we did in the book yesterday worked out nicely because your x's and y's changed by the same in the table. However, sometimes that's not always apparent when you just look at numbers because there's a gap here, because technically you have a 0.5 and it has some coordinate y, but you're not given that. So when you look at the problems in your journal, at first you would say number 19 and 20 both are not linear. However, when you use y2 minus y1 over x2 minus x1, you can find that the slope between these points are the same between these points. So what I mean by that is if this is y2 and this is y1, this is x2 and this is x1, y2 is negative 60 minus negative 110 over negative 1 minus negative 3. So on top, you would get 50, and on bottom you get 2. 50 divided by 2 is 25. Okay, if I do the same thing with these coordinates, y2, y1, x2, x1, I would do 40 minus negative 10 over 3 minus 1. I would get 50 over 2, which again is the same as 25. So finding the slope between different points will also determine whether it has a constant rate of change. So now that I've found a constant rate of change, which is 25, I'm going to write it as a linear equation. Your linear equation is always going to be in the form y equals mx plus b. So I have the slope. I do know what the y-intercept is because when x is 0, y is negative 35. Therefore, y equals 25x minus 35. On number 20, if I again find two slopes between two different points, I have y2, y1, x2, x1. y2 is 18 minus a negative 98 over x2 is negative 1 minus a negative 3. 18 plus 98 gives us 116 over 2, which simplifies to 58. Okay, if I pick two different points, y2, y1, x2, x1, I do the same thing. y2 is 142 minus 62 over 3 minus 1. 142 minus 62 gives me 80 over 2, which simplifies to 40. 58 and 40 are not the same, therefore there is no constant rate of change. And it's not linear. Okay. Then the last one in your journal is number 21, and it's a story problem. So Craig is driving at a constant rate of speed of 60 miles per hour. After driving 3 hours, his odometer reads 265 miles. Write a linear function d that represents the miles driven after 8 hours. What does the odometer read after 7 hours of continuous driving? Okay, so we're going to write it in a linear function, which means it's going to be in the form d of h equals mx plus b. We are given the rate of change is 60, so that would be our slope, but we don't know how many miles we started driving before we were at 60 miles per hour. Therefore, we're actually going to write it into point slope form, which is y minus y1 equals m parentheses x minus x1 to find the y-intercept. So since we are given a coordinate point after driving 3, and since h is my x coordinate, it would be my x, and then 265m, and that's my y coordinate. So y minus 265 equals, my slope is 60, x minus 265. To solve, I'm first going to distribute. So I get 60x minus hold on a second, we did something wrong here. Okay, I accidentally put my y and my x. So that was not right. Okay, so that was my y, so this is my x, minus 3. So then 60 times 3 is negative 180 minus 265. So to get y by itself, I would add 265. Y equals 60x plus 85. And therefore it is in slope-intercept form. Therefore I'm going to rewrite it into function notation. So d of h equals 60x plus 85. And that is the final answer.